All right, friends, welcome back. In this video, I'd like to take a second opportunity to talk about Section 3.3 from your textbook. In this video specifically, we're not going to really be covering any new topics, but we are going to be covering how to use synthetic division to do a couple of neat things in the world of algebra, right? So in the last video, if you hadn't had an opportunity to catch that, I would definitely encourage you to do that. We talked about how to use synthetic division to evaluate functions, and that's the first thing that we're going to be doing here in this video and just reviewing that a little bit. So it just says use synthetic division to evaluate the function for the indicated value of x. We were given the function f of x is equal to 4x to the third minus 13x plus 10. And again, remember the most important thing that we could be doing here is making sure first that it's in standard form. So I think that it is, right? All of the variables have exponents that are in descending order. And also we need to introduce a placeholder for terms that we might be missing. And so we are, of course, missing the x squared term here. And so remember how we introduced that in the last video is we introduced a plus 0x squared for us, okay? And so now in this first example, we just want to simply see about taking an input of 1 and plugging it into this function and seeing what we would get as the output. Now again, in 2021 we have calculators, and that's something that we can very easily do in a matter of seconds, but back in the day, before the days of calculators, they would have to do a problem like this to make that process a little bit simpler for them to have to calculate. So let's get started with that, right? So we have a value of 1. We're going to go ahead and write that down as the number that goes in my little corner box symbol, and then we're going to go ahead and follow up with a list of all the different coefficients from my dividend up there. So we have a 4, a 0, a negative 13, and a 10. So again, if you need more information about how to set this up, again, I would encourage you to go ahead and take a quick peek at the previous video to this, the 3.3 day 1 video, and that will shed some light on that. But let's go ahead and continue here. So we're going to drop the first number and then multiply and then add and then multiply and then add and then multiply and then add. Okay, actually that is going to give you a positive 1. There we go. So we see here that we end up with a remainder of 1. Remember, that was always the final number in synthetic division, and then the numbers that come before those would be the coefficients and constant of your quotient, so the answer to your division problem. But for our purposes here, what we're interested in is basically what is f of 1. And so the way we would interpret that is that we would basically just look to the remainder of what we've got. Okay, so the remainder after doing the synthetic division would just simply be 1, and so we can go ahead and answer this question really easily. If we plug in 1 into this function, apparently we're going to get out 1. So that would be the answer to the question, and again, that would be done by synthetic division there, so really easily, okay? I've done the next example here for us. So here I have an input of negative 2, and of course we're interested in figuring out, what is the output if I were to plug in negative 2 as the input? Well, we can see here, according to my synthetic division work here, that we end up with a remainder of 4, and so what that means is we don't need to bother plugging into the calculator. We could just go ahead and do this simply on our own, and we can go ahead and get that answer regardless here by what we call the remainder theorem in algebra. Okay, so those are some basic problems. Again, we talked about how to do that briefly in the last video. Looks like I already wrote the answer over there, so whatever, ignore that. So again, just some more examples of that very same type of thing, okay? It turns out that we can actually go ahead and do some more with synthetic division, and I'd like to go ahead and demonstrate that here right now. So example 2, it says use synthetic division to show that x is a 0, and then use the result to factor the polynomial completely. So before we move on to that, what I want to do here is basically just kind of go back over just a little bit what it is they're referring to here in the directions. So first of all, if they want us to show that x is equal, or sorry, not is equal to 0, but they want us to show that x is a 0, remember what that means, right? Remember that means if you were to go ahead and plug in that input, then it's going to output the number 0, okay? And so that is what is meant by x being a 0, okay? Now, one of the other things that we've talked about earlier is that if you have a 0, then that automatically corresponds to a factor, right? So let's say here that we have a number that is a, and a is a 0, meaning that if I were to plug a into my machine, the output would be 0, okay? If that's the case, if a is a 0 of my polynomial, then as far as the factor is concerned, that factor would look exactly like x minus the number a in the factorization, okay? So anytime you can show that you have a 0, that is a way that you can show that you have a specific factor in your factorization, okay? And that's exactly what we're going to go ahead and do here in these problems. We're first going to show that the number that we are given is a 0 of the polynomial, and then after that we're going to show that that corresponds to a factor, and then use that to factor the polynomial completely, okay? And so here we have this example. We are given this polynomial equation, and we're given this value for x, okay? So again, one of the things that we need to check to make sure is that our polynomial is written in standard form. I do believe that it is. We are going to go ahead and need ourselves a placeholder here for our x squared term, so we'll just say plus 0x there in the polynomial, and then we're going to go ahead and set up our synthetic division, right? So our number that we want to test is -4. And we're going to go ahead and list out all the coefficients and the constant of my polynomial here. So that's going to be a 1, 0, -28, -48 in that order. Okay? And so going ahead and setting this up in the synthetic division here, we can go ahead and execute that process, right? You might need a calculator handy to do this. Your numbers may get a little bit big, but we'll see, right? So we're going to drop that first number, and then multiply, and then add, and then multiply, and then add. So that's going to be a -28 plus 16. I do believe that's going to give us a -12. And then multiplying -4 times -12 is going to give us a positive 48. And then if we add those columns, we get a remainder of 0. Okay? So just by virtue of the fact that your remainder here actually ended up being 0, remember what that means according to what we just talked about. The remainder theorem says that if this is our remainder, then that must mean that if I were to take my polynomial and plug in -4 as the input, then that means I get 0 as the output. So what that means by definition is that -4 is a 0 of this polynomial. And I'm just doing a lot of writing here just to kind of explain what the thought process is. When I'm looking at your homeworks and quizzes and tests and that kind of thing, if I don't see this much detail, it's you know, not going to be something I'm going to count you off for. I definitely do need to see your synthetic division and you showing me that the remainder happens to be 0, but here I'm just being explicit. Okay? And so if -4 is a 0, then that automatically corresponds to an algebraic factor in the factored form. Okay? So that factor would look like x plus 4, because if I were to set x plus 4 equal to 0 and solve, I would get that -4 back that I said was my 0. Okay? And so what that means is that I can go ahead and rewrite the original polynomial that I was given in terms of a factorization that I might go ahead and write down here, which kind of begs the question, well, if x plus 4 is a factor, then what is the other factor? Well, you need look no further than the actual quotient that you arrived at when you did your synthetic division, okay? So kind of working backwards here again, that middle term, that would be your x term, and that first term would be your x squared term, and so we can go ahead and write out a complete factorization by picking up here with an x squared minus 4x minus 12, okay? And that is something that in the original problem they set equal to 0, so we'll do the same thing, all right? And so now what we may want to do in our effort to factor this completely is just go back to our factoring skills and make sure to factor what I've got left over here, and then we'll get the zeros from that and we'll be done with the problem, right? And so we don't have to do synthetic division again. What we'll do here is just use our good old factoring toolkit, right? So we have our x plus 4 from out front, and then this trinomial, if it factors, will factor into the product of two binomials. I'm basically just going to unfoil this. So I have x, and then I'm looking for two numbers that multiply to make me -12, but add to make -4. And if you think about that for a moment, maybe some combination of 2 and 6 would work out for us here, okay? I would, of course, want to go ahead and have a -6 and a +2 so that they would add up to -4. And then, of course, -6 times +2 would give us that -12, okay? And so what you have right here, folks, is a complete factorization of the polynomial that we were originally given, which is really cool because if I were to just kind of put that polynomial in front of you in the first place and just say factor it, we may not have a lot of tools in our toolbox for being able to do that. But now that we've talked about synthetic division, we can go ahead and use that to prove that we have zeros, and those zeros always correspond to algebraic factors in this way. So that's pretty good. And then, of course, if we wanted to go one step further, we could make an actual list of all of the zeros of this polynomial by just setting each one of these factors individually equal to 0 and solving here. So I would have the x is equal to -4 that we had from before, but then also here I'd have x is equal to 6 and x is equal to -2, and these would be the three zeros of this polynomial. Okay, and that's actually pretty cool. So we are adding some new strategies to your toolbox for being able to find zeros of polynomials. Synthetic division is a very, very handy tool for being able to do just that. Okay. So I'm going to go ahead and move on to the next example, which will be the last example that we do. And this is going to be a little bit more challenging because you notice that the number that we're working with here is actually the square root of 2. So it's a square root number. So let's find out how we're going to have a different problem where this is involved. So that number, square root of 2, I'm going to go ahead and write that in my little corner box here. And then I'm going to go ahead and list out all of the coefficients of my polynomial. It looks like it's in standard form. I'm not missing any terms in the sequence, so I don't need to do any substitutions. I'm just going to go and write out all of the coefficients here. So 1, 2, -2, and then -4. Okay? Now, the reason that this is going to be a little bit more challenging is because after we drop the 1, we're going to go ahead and multiply just like we always did, right? So the square root of 2 times 1 is going to give us the square root of 2. And now we kind of run into a conundrum because we now have to go ahead and think about how we're going to add this column. Well, if you remember anything about square root numbers, you may remember that they are not numbers that add to integers very nicely without resorting to a big, long, ugly decimal, okay? And so for our purposes here, what I'd like us to do is just to go ahead and write this out as an actual expression, okay? If I have to take 2 plus the square root of 2, I'm just going to write that out. 2, well, maybe switch back to my pen. 2 plus the square root of 2 is what I would get as a result of that, okay? So you can now start to notice how this is going to shake out, right? Because we now have to do that next iterative process, which means I've got to take that 2 and multiply it times what I've got down there, and that's what I put up into my new space. And so if you think about that, right, I basically got the square root of 2 times 2 plus the square root of 2, okay? So maybe do this work off to the side, right? If I have to do the square root of 2 times 2 plus the square root of 2. Let's see how that shakes out. So we're going to do distributive property here. So square root of 2 times 2, this would just simply equal 2 square root of 2. That's how we would always write that. And then the square root of 2 distributed to that other square root of 2, if you multiply those together, by definition, the square root of 2 times square root of 2 is just simply going to give you 2. Okay? And so that is going to be the result that we are going to go ahead and write in this next available space. So 2 square root of 2 plus 2 is what we're going to write there. All right? Now, again, we're going to go ahead and pick up with our synthetic division process by now adding the columns, okay? And a pretty neat thing that happens here is you may notice that because I am taking a -2 and I'm adding it to something that has a +2 in it, those would actually be something that cancels out here for me, and I'm just going to simply be left here with 2 square root of 2 as the result after that addition, okay? And then you guessed it, we are going to go ahead and take that one last time and write that as the new result. Okay, so again, if I do this over here off to the side, maybe some scratch work, I'm going to be taking a square root of 2 times 2 square root of 2, and we're going to see how this shakes out, right? Well, if I go ahead and multiply, again, the square root of 2 times the square root of 2, that's just simply 2, and then I just need to multiply times that remaining copy of 2 there, and we can see that that's just going to end up being 4 here for us, okay? And so that is going to be a result of 4, and we can now see -4 plus 4, that's going to give you a remainder of 0, okay? Now, I do need you guys to kind of get on the board with kind of going through that thinking process of dealing with all those expressions with the square root of 2 because we are going to need that for later on in our factorization, okay? Well, we can now see that we ended up here with a remainder of 0, and what that is going to mean is that, of course, if I were to plug in this square root of 2 into my function, I would be getting 0 out. That's what we just showed by the remainder theorem, okay? And so what that's going to mean is that square root of 2 is a 0. And of course, if that is a 0, then that corresponds to an algebraic factor of my polynomial here. So I can go ahead and write that factor out as x minus the number that was my 0, which of course here, that is the square root of 2, okay? Now again, what is the rest of that factorization going to look like? Well, we look no further than the actual quotient that we ended up with up here. Again, the way that we interpret this is that that last number is the constant. The one that comes next is the one with the x next to it. Again, since that's an expression, I'm going to lump that in a set of parentheses and then say x. And then the one that came before it, that is my x squared term, okay? And so we're going to go ahead and write that out. That is going to be x squared plus 2 plus the square root of 2 times x plus 2 square roots of 2. And that is equal to 0, okay? So again, I know that this looks a little bit complicated because we're dealing with so many square roots of 2, but we now need to go through and do our typical factoring skills to go ahead and factor the remaining here. And that may look like a pretty daunting task, but remember that it's a trinomial, so that if it does factor, then it's going to factor into the product of two binomials, which I'll just go ahead and write two sets of parentheses here. I see here that my first term is just simply x squared, and so that means I'm going to go ahead and write my first terms as x and x. And then, listen very carefully, right? We need two numbers that are going to multiply to make 2 square root of 2. But those same two numbers need to add to make 2 plus the square root of 2. Think real hard, okay? If they need to multiply to make this number and then add to make this number, why not just use the numbers that are already sitting here for us, okay? So that is going to be positive 2 and positive square root of 2, okay? So again, I know that this looks difficult because we're dealing with those square root numbers, but if you take this back to what we're actually just trying to find, it turns out to not be that big of a deal. We can go ahead and get this factorization, which is something that they asked for, so I will go ahead and box this. And if we wanted to go a step further and get all the different zeros from this, we absolutely could do that now. All the zeros we have here are going to be the positive square root of 2, we have negative 2, and then we have the negative square root of 2. Those would be all the zeros of this polynomial. And then we could take it from there. We could do all sorts of different other things like find the x-intercepts and make a quick sketch of this function just like we've talked about how to do in previous classes. So there we go. Okay, so when you have a problem dealing with a square root number like that, it is going to be something that you do have to think a little bit extra on, but it's not really anything too different. Okay, it's just going to be a little bit extra work. All right, so that is all I have for this video. Thank you very much for your attention. As always, if you guys have any questions whatsoever, please feel free to let me know, but I will speak with you guys in the next one.